continuation of our numerical example, Buyer's Digest has conducted the same test but on 10 other thermostats. This time it tests thermostats manufactured by Temp King. The temperature readings of the 10 thermostats are listed below. We will conduct a hypothesis test at the 10% level of significance to see if the variances are equal for both thermostats. We already know the 10 values, variance, and degrees of freedom for thermal-right thermostats. The results of sampling indicate the first thermostat picked off Temp King's production line at random kept the test room at 67.7 degrees Fahrenheit, even though the thermostat in the test room was set at 68 degrees Fahrenheit. The second thermostat picked off of Temp King's production line at random kept the test room at 66 degrees Fahrenheit, even though it was set at 68 degrees Fahrenheit. The third thermostat picked off Temp King's production line at random kept the test room at 69.2 degrees Fahrenheit, even though it was set at 68 degrees Fahrenheit. The rest of the thermostats kept the room temperature between 66.6 and 70.1 degrees Fahrenheit. The degrees of freedom for this sample are 9. The variance of the sample needs to be determined if the sample variance is larger than Thermalright's. Temp King thermostats comprise population 1. If the sample variance is smaller than Thermalright's, Thermalright thermostats comprise population 1. To compute the standard deviation, we need to compute the sample mean, which is the sum of the x values divided by the sample size. The sum of the values of x is 682.1 degrees Fahrenheit. Dividing this by 10 yields a sample mean 68.21 degrees Fahrenheit. The first deviation from the mean is negative 0.51 degrees. The first square deviation from the sample mean is 0.2601 degrees Fahrenheit squared. The second deviation from the sample mean is negative 1.81 degrees. The second square deviation from the sample mean is 3.2761 degrees squared. The third deviation from the sample mean is 0.99 degrees. The third square deviation from the sample mean is 0.9801 degrees squared. The remaining deviation from the sample mean range from negative 1.61 to 1.89 degrees. The remaining square deviations from the mean range from 0.0121 to 3.5721 degrees squared. The sum of square deviations is 15.909 degrees squared. Dividing this by 10 minus 1 yields a sample variance of 1.768 degrees squared. Since Temp King's sample variance is larger than Thermalright's, sample 1 variance is 1.738 and sample 2's variance is equal to 0.7. That is, thermostats produced by Temp King comprise population 1. Since we are asked to conduct a hypothesis to see if the variances of the thermostats were equal using a 10% level of significance, the null hypothesis is the two population variances are equal. The alternative hypothesis is the two population variances are not equal. The test statistic that we call f-stat is equal to the larger sample variance divided by the smaller sample variance, which is equal to 1.768 divided by 0.7, or 2.53. There are two critical values for this test because this is a two-tailed test, but since the f statistic is always greater than or equal to 1, because the larger sample variance is in the numerator, we only need to find the upper critical value. The upper critical value is found in the F distribution table. Since there were 10 thermostats collected from Temp King, population 1 and temp king sample variance is in the numerator of the F statistic, the numerator degrees of freedom are equal to 10 minus 1 or 9. The upper critical value of this test is in this column. Since there were 10 thermostats collected from thermalright population 2 and thermalright sample variance is in the denominator of the F statistic, the denominator degrees of freedom are equal to 10 minus 1 or 9. The upper critical value of this test is in this group of rows. Since this was a two-tailed test, we divide the significance level by 2, which is 0.10 divided by 2, or 0.05. Hence, the upper critical value is 3.18. Since this is a two-tailed test, there are two critical values. The lower critical value, denoted F subscript 0.95, is not needed because the larger sample variance is always in the numerator of the F stat, making its value less than 1. The mean is always bigger than the lower critical value because it is approximately equal to 1. The upper critical value was found in the F distribution table, which we found to be equal to 3.18. The significance level, 0.1 in this case, is divided by 2 because there are two tails. The upper and lower critical values define the reject the null and do not reject the null regions. The F stat is equal to 2.53, which means it is between the upper critical value, 3.18, and the mean of the distribution, approximately equal to 1. Thus, we cannot reject the null hypothesis. This means there is insufficient evidence to conclude that the population variances differ for the two thermostat brands, meaning that the variances of the two are the same, essentially. Complete homework 11 on Blackboard.